All right, I'm going to try to wake you all up. I'll do my best. I'm Gabe Cahalan. I work for the Nature Conservancy, the Maryland, DC chapter as the fire manager. And we've been doing a lot of burning at a preserve down the road here, Nassawango Creek Preserve. And I'm going to talk about some acoustic monitoring that we've done for birds. Who's got a favorite bird song? Anybody? All right, what bird? A what?
American bittern.
Bittern, okay. Anybody else? Meadowlark, all right. Some great birds. Well, let's see. I'm going to talk about a couple of birds. You heard Bob Long talk about the quail. Let's see, I'm having the same issue. Okay, there we go. So hopefully we don't see this sign out here on campus anywhere. This was at a university that I recently went to in Japan. They don't want any use of fire out there. All right, so just to place the study site on the map, Nassawango is here on the peninsula near Salisbury. And I'm going to talk a little bit, just give a little bit of background about the comparison that we made using bioacoustics. So we wanted to look at how closed canopy forests versus open canopy forests affected bird diversity. And this was prompted by some observations that we had on the preserve after burning for, over a decade, that we had an increase in red-headed woodpeckers nesting in the burned plots. And this paper came out in 2008 talking about an association for the red-headed woodpecker with fire. So we decided, let's take a look at that. And let's pick some species of conservation concern. So I'm showing you the graph that I think Bob said he didn't want to show you earlier because it made him cry. The steep curve here is the northern bobwhite quail. And then you've got a number of other species. So one of the ones that I'm going to talk to you about, in addition to the red-headed woodpecker, is prairie warbler, which is one of these species that's in decline. It's of conservation concern. And we often talk about these species as early successional. Bob had a great graphic showing forest succession. But this paper that I'm showing you here, this graphic from March 2019 in Wildlife Society Bulletin, was asking the question, well, we've actually got a slight increase, or at least maintaining the percent of successional forests. And a lot of these birds are actually very site selective. So, prairie warbler is a bird that migrates, but it's coming back to these same spots. And as Bob mentioned, you only have this short window where successional forest, early successional forest, stays open enough to provide benefits, and then it closes right back up to closed canopy. So the site that we picked was this tract here. We often call it the Johnson tract. It's about 1,500 acres. And then the other site we were comparing it to is right here. We often call this one the Bear Swamp, or Atkins 10 and 11. And each of these corresponds to either the closed forest spectrum. So I wish I had a better graphic that was kind of like Bob's, that was easier to understand. But essentially, number 4 here, this is surface fire. So when you have a loss of surface fire, you end up on this closed forest spectrum, where as the forest goes through succession, it's pretty much a closed canopy the entire time. So that's what this is showing. So early successional closed forest, mid-successional closed forest, late successional closed forest, and then there might be a major disturbance back to early. But if you add fire in, surface fire, then you're on this spectrum. So it's either more or less frequent surface fire, and you have with less tree abundance, then you've actually got more herbaceous because of that sunlight that's getting to the forest floor. So you're somewhere on this spectrum, and the two sites we picked to compare, where we had been burning and doing some thinning, were on this spectrum. And then this one where we hadn't, when we first started the study, it was on this closed forest spectrum. So what does that actually look like? Here's the open forest. What we did was we deployed these audio moth recorders, and this is the homemade case that's in there. The recorders are they can fit in the palm of your hand, and they record audio to an SD card. So you can, with the miniaturization of technology, you can record hours of audio onto a small SD card. So this wasn't possible really before the SD card came online and became affordable. So essentially, we just zip tie the recorders to the tree. And what I want to point out is this abundant sunshine in this plot here. And you can see ground cover here, and shrub cover, grasses, and herbaceous cover. So all those things that Bob talked about, the northern bobwhite quail requiring. And then we also put them out on that other tract of land that's on that closed forest spectrum. So here you can see there's some greenbrier vines, but for the most part, it's a kind of a densely packed, high trees per acre forest. All right, so getting to some results. There are kind of two main ways to look at acoustic data. You can actually identify specific bird species or animal species, or you can look at what are called acoustic indices. Remember that you're recording any animal that makes a sound, it's going to record it. So we're talking about frogs, insects, birds, all of that gets recorded. And there's something like 80 or potentially even over 100 different types of acoustic indices that can be calculated. But I'm showing you just a couple that have been shown to correlate better with bird diversity. So one of the things that we did was put the recorders out there during peak breeding season. So right after all the migrants have moved through, the actual resident birds are singing. So we're talking like late May time period. And so that's what I was targeting with the recorders. And so those two sampling areas I showed you, this is called the acoustic complexity index. And here's the closed canopy and the open canopy, or burned and unburned plots. And we had a higher acoustic complexity index there. And then over here, this is the bioacoustic index. Again, a higher average bioacoustic index in the burned versus the unburned. So the acoustic indexes are great, but it doesn't tell you what species are out there or the number of species. So this is just showing that acoustic index again. So in the kind of reddish color here, that's the burned plot, the mean bioacoustic index across all the plots. And then this is the unburned plot for the acoustic index. And this spike you see here is the dawn chorus. So this is from 4 a.m. to 10 a.m. So on average, there's more happening in the burn plot is what you should take away from this graph. So again, as I was saying, the indexes don't give you specific species, but we can use programming to pick out specific songs and then identify them to species. So this is showing the prairie warbler and an eastern towhee from a recording at Nassawango in the burn site. And then sort of very recently, Cornell put out this model called BirdNet. It's the same if you've ever used the app on your phone to like record birds and ID them. It's the same model that's running in the background that does that. It uses machine learning on bird songs to identify to the species. So I analyzed 4 hours of recording that were taken on in 2018, 24 recorders, 12 in the unburned and 12 in the burned areas. And the total species detected in 2018 was 114. A little bit of a caveat there is that even with BirdNet, it's really good at identifying birds, but those still need to be verified. So I just want to make sure that I'm showing that, but they still need to be verified. Unburned number of species detected was 87, and in the frequently burned plot, the open forest, there was 102. And then in 2023, looking at a similar comparison, but some of these recorders were in once burned versus 2 in frequently burned. And we had a similar breakdown, burned once 109, and then frequently burned 131 species. So this is the prairie warbler and the red-headed woodpecker here. Total number of prairie warbler detections, 3,746. And the prairie warbler detections in the once burn, 51. So they're starting to come back after one burn. And then 567 red-headed woodpecker detections total. And the big takeaway is that 98% of all the prairie warbler detections were in the frequently burned forest, and 100% of red-headed woodpecker detections were in the burned forest. So these birds are definitely using that habitat in preference over the closed forest. And these two species, I did verify those detections, to make sure that they were what the BirdNet was saying they were. And then up top here, this is just showing this very similar results in 2018 as the 2023 results. So a couple of acknowledgements. Thank you to a donor for funding the work. And then big thanks to all the partners who've helped, do the burning over the years. And with that, I can take some questions. Yeah.
I'm just curious as to, do those mess up your audio surveys if you get a lot of mockingbirds in the same area?
Yeah. So the question was about mockingbirds and whether or not they would mess up the data if we had a lot of mockingbirds there. There are certain bird species that are actually difficult for the machine learning programming, and mockingbirds and the brown thrasher is another one that has like a wide variety of songs that it sings, and those are actually difficult for the model to learn. But we don't have a lot of mockingbirds in these study sites, so luckily. Anybody else? Any other questions?
Yeah, there was a question on Zoom, and I think I was going to answer it here, but could you explain, how do you know that you're not just detecting the one bird many times over? And I believe your results are showing how many calls you got, not necessarily how many birds were present. Is that?
That's right, right. So the way the software works is it's just detecting. So if I go back to here, this was probably the same bird calling over and over again. So it is measuring number of calls. So it's not telling us how many birds are out there. All right.
All right. Awesome.
Thanks.